My name is Lowen Singh, and today our group will introduce about the Chinese Lunar Exploration Program. Chinese Lunar Exploration Program, also called Chang'e Project, and it is the most ambitious space exploration program in the world today. So the journey started in the year 2000 when lunar explorations was the first included in China National Space Development Plan. And by 2004, the program was officially approved, launching a mission that would gradually change our understanding of the lunar. And the Chang'e project also follows a step-by-step plan, which is orbiting, landing, sample return, and the future. So one of the most important program is the Chang'e-5, which represents the sample return phase. In 2020, Chang'e-5 has successfully collected and brought back the about 1.731 kilograms of the lunar sample. So this achievement made China one of the few countries in the world to successfully return sample from the moon. The success of Chang'e-5 is important for two main reasons. So first, it demonstrates the Chinese advancement in space technology, so especially in the areas such as automated landing and the sample return. Second, the lunar sample has provided valuable scientific data, so it will helping the researchers to understand the information of the moon and the history of the universe.
So, now I will talk about the purpose. The Chang'e-5 mission is China Lunar Exploration Program. It includes an orbiter, lander, and rover. The main purpose of the satellite is to carry out scientific research on the moon. Let the country to understand the physical and chemical properties of the moon. This satellite is used to survey the surface of the moon and explore the topography. Also can use to examine the mineral content of the moon's surface and identify potential resources, for example, water ice. Next is technology development. This satellite is used to test and demonstrate new and advanced space technologies. This included precise orbiter maneuvers, soft landing technology, autonomous navigation, and remote sensing technology. This satellite will not only contribute to the accumulation of scientific knowledge, and also aid in the development of future lunar exploration missions, including manned missions. This satellite can improve image resolution and acquire on-site measurement data. Also help identify the landing site of subsequent missions and gain more insight into the evolution of the Earth's geology. The information gathered is also going to help us understand the formation and evolution of the moon and its relationship to the Earth. Finally, the satellite has both scientific and technological significance in helping us know more about the moon and how further explore it and advance China's capabilities in space exploration.
Hello, my name is Chang'e-5, and now I will explain the working mechanism. First, the mission starts by launching a spacecraft from Earth using a launch vehicle. The spacecraft is sent into an Earth-Moon transfer orbit, which allows it to travel from Earth toward the Moon. As it moves closer to the Moon, the spacecraft makes small adjustments to its direction and speed. This helps it stay on the correct path and reach the Moon safely. Before entering lunar orbit, the spacecraft must slow down. This is called a braking maneuver. It allows the spacecraft to be pulled in by the Moon's gravity and enter a stable orbit around the Moon. Next, the spacecraft separates into several parts, including an orbiter, a lander, an ascent module, and the return module. Each part has its own role, and together they form a complete system for the mission. The lander then moves down and lands on the Moon's surface. After landing, the rover is sent up to explore the surrounding area. It can move across the surface, take pictures, and collect soil and rock samples. The system is also able to detect obstacles and choose a safe landing site before landing. This helps reduce the risk and makes the mission safer. After landing, the lander and rover carry out scientific work. They study the lunar environment and collect data which help scientists understand the moon's structure and the possible resource. For missions on the far side of the moon, communication becomes a big problem. This is because the moon blocks the radio signals, so direct communication with Earth is not possible. To solve this problem, relay satellites such as Chang'e-5 are used. These satellites are placed in special positions in space so they can stay in contact with both the spacecraft and the Earth. This allows data to be sent back in real time and the mission can be monitored continuously. Finally, after the samples are collected, the return process begins. The ascent module takes off from the moon and goes back into orbit. It then connects with the orbiter and the connected samples are transferred into a return capsule. The return capsule then travels back to Earth and re-enters the atmosphere. It safely lands and delivers the samples back to the Earth for future research. Overall, the mission includes many stages such as launch, landing, exploration, communication, and return. Each step must be done very carefully and accurately to.
Now, I would like to share about the contribution of Chang'e-5. In December 2020, Chang'e-5 has successfully returned to Earth, carrying 1,731 grams of lunar sample. And this one not only China's first time collecting sample from the moon, but also a test example for a space relay race. Why a relay race? Because it at the for history first of China, 380,000 kilometers west for Earth, first lunar surface sampling, first access from the moon, first unmanned reverse and docking in lunar orbit, and first keep re-entry at the second comet velocity. These technology breakthroughs have paved the way for future crewed lunar mission and deep space exploration. But what true assisted the scientific community was the lunar solar it probed perceivably or existing lunar samples were over 3 billion years ago. Chang'e-5, however, returned samples from just 2 billion years ago, a younger lunar sample ever collected. This discovery extended the moon's geological lifespan by 80 million to 1 million years and completely renewed our understanding of lunar evolution. Moreover, scientists discovered a new lunar mineral, Chang'e-6, along with solar with derived water and organic matter in this sample. These findings not only advantaged lunar science but also open up to possibilities for future utilization of lunar resources. Finally, China has opened this private sample to scientists around the world, welcoming collaborative research. The success of Chang'e-5 belongs to China, but it also belongs to all humanity.
I am currently now writing the final part. Conclusion. The Chang'e-5 mission represented an important lunar exploration. It has helped develop more advanced space technology and improve our understanding of the universe. In terms of technology, The Chang'e-5 uses a multimodal system that adds an orbiter, lander, a Dardan, and return module to complete the field product from orbiting the Moon to landing and returning damaged back to Earth. These products involve key technology such as precise orbit control, automatic orbit call during landing, and orbit docking, which improves the reliability and autonomy of space missions. In terms of scientific understanding, the Chang'e collide and return lunar dust and rock samples to provide evidence of studying the Moon composition and evolution. Their samples help scientists better understand how the Moon formed, but also provide important clues about the early history of the Earth and the solar system. Therefore, the Chang'e-5 advanced space technology. It also expands our understanding of the origin and evolution of the universe. In conclusion, the Chang'e-5 shows Chinese progress in space technology and help us better understand the Moon and Wind universe. As technology continues to develop, humans will have the opportunity to explore deep into space. Thank you for your work.